Hello friends, thank you for watching this video. I am Mohamad and today we're going to be discussing how we can actually deploy our .NET Web API into Kubernetes. We're going to be utilizing a local Kubernetes cluster on our own machine, and we're going to be seeing step by step how we can actually create our application, create a Docker image, and then deploy it to our Kubernetes cluster. If you like this video, please like, share and subscribe. It will really help the channel. As well, if you'd like to support me, please consider supporting me on Patreon or buying me a coffee. Now, grab your cup of coffee and let's get started. So the first thing that we need to do is we need to make sure that we have the basic requirements available on our machine. We're going to be needing a .NET SDK and we're going to be needing Docker installed on our machine. And once we have those installed and make sure that they are running as they should be, we can actually start coding our application. So let's do these checks right now. So inside our terminal, what we're going to be doing is we're going to be checking our .NET version, .NET -- version. And as you can see, I'm currently running on version 7.0.2.3, which is going to be the latest version by the time of this recording. And as for Docker, I'm just going to run it right now. But if you don't have it, you can go directly to zoom in, go to Google, type download Docker, and it will take you to this link. Inside here, just make sure you download based on your own machine. So currently I'm on a Mac, so you download, if you're on a Mac, on Windows or Linux, make sure you download it and install it. And once it's downloaded and installed successfully, all you need to do is, once you run it, you're going to be seeing on the top right hand side, you're going to see like a whale icon. And once you open it up, you're going to be seeing something like this. And basically it's going to show you everything which is available on your machine. For you it might be empty. For me, because I have some containers available, it's already being populated. As well, the second thing that you need to do once you have downloaded and installed, you need to go to settings, and you need to go all the way down to Kubernetes and make sure you enable both of them and click on apply and restart. So once you have all of this ready, we made sure that our .NET SDK is available. We have made sure that Docker is installed on our machine and running, as well as Kubernetes instances are also available locally on our machine. Once you have done all of that, the next step is you need to go to hub.docker.com, and I highly suggest that you create an account here, because we're going to be needing it to push our images. It's a free service. You can have one private directory, one private repository, and as many as you want public ones. So please create also an account on Docker Hub. So now that we have these three information available, or basically the SDK, the Docker instance installed on our machine with Kubernetes enables, and we have a Docker Hub account, now we can actually able to start our application and basically start coding. So what I'm going to be doing is I'm just going to go back to my terminal. I'm going to go to my desktop, work, learning, .NET, Kubernetes, and inside this directory I'm going to create a new application, and so it's going to be a very simple application. So it's going to put .NET new web API, and I'm just going to call this, let's say, formula 1 Kubernetes. Pretty straightforward. And just so we make sure that this application is unique. So now that we have created it, it's going to take a few seconds. Now let's navigate to it. And now all we're going to be doing is just going to open it in Visual Studio Code. Perfect. So once we have done that, the first thing that we're going to be doing is we're just going to add some minor modification for this to make sure that this is all running as it should be, and it's running basically our own instance. So inside my controllers here, we have a weather forecast, which is by default bootstrap when we create our application. I'm just going to change the summary here to hello from my local app, something like that, just to make sure that's different. Now let's open our terminal, and I'm just going to do .NET run. Okay, perfect. Let's copy this. And let's go back to our web browser. Let's open this here. /swagger /index.html. And now you can see here I have my weather forecast controller. And if I open on this and click on try it out, then execute, we'll be able to see that I have hello from my local app, and then I have the actual weather forecast. Okay, great. So now that my application is running locally, what I want to do as well is I want to go back to my program.cs, and I want to make sure Swagger is available for me anywhere. I don't want it just in development mode, because basically right now what we're going to be doing is we're going to be publishing our application. I just want it to be available. And I don't want this, so let's delete this. And I want to remove the HTTPS redirection for now, because I don't really need it. That's going to be a completely different topic. So for simplicity's sake, I just made some changes to my API, so make sure that I customize it a bit. And then what I did from there is I just enabled Swagger even in production mode. It's just again for testing, and of course in a real life scenario you should not do that. And lastly, I just removed the HTTPS redirection because right now we don't really need it. So now once we have done that, I'm gonna stop my application. And what I want to do here is in our root directory, I want to create a new file. And this file, I'm just going to call it Docker file. Pretty straightforward. And what I'm going to be doing here right now, I'm not going to be delving into how Docker works in the background. I have a different video which basically explains how everything works within Docker. But just a quick overview, Docker is like a virtualization platform where basically we are running our application in a containerized way, where basically it has all of the available SDKs, libraries, any dependency that it needs is all available within the same Docker instance and Docker container. And that way we're basically making sure that our application have all of everything that it needs to run. We're not relying on any third-party dependency which is not available currently inside the Docker container. And what we're going to be doing right now is we're going to be containerizing our .NET application. And basically once we containerize it, we're going to be seeing how we can actually deploy it to a Kubernetes instance. So right now, let us start firstly by getting a base image, and we're going to be utilizing mcr.microsoft.com /.net /SDK 7.0, and then we're going to just put as this is going to be our build environment. And this is basically the base image we're going to be utilizing in order for us to basically create our application and deploy it. The second thing is we're going to specify our work directory. And it's going to be simply /app, which is going to be a folder inside that instance that we need. And then I'm just going to expose ports. I'm going to expose port 80. I'm just going to expose also port 443. Although we have disabled it, but it's always good to expose it. Perfect. Now the next step is I want to copy my CS proj to the root directory, and then I'm just going to run a command which is going to be .NET restore, and basically here I'm going to restore all of the dependency for my application. Then what I'm going to do, I'm going to copy everything else, and once I do that, I'm just going to run .NET publish -c release, and I'm gonna put it in an output file. Perfect. Once that is done, I'm gonna get another base image. And here all I'm going to be doing is specifying a work directory inside this work image. And then I'm going to copy whatever I published from the first image to the final image. And then I need to specify that I want to copy everything. And lastly, I want to specify my entry point. And in this case, it's going to be .NET. And we'll call it formula 1. Formula 1 to DLL. Let's double check this in the bin folder. Formula 1 KAX. Okay, perfect. So now let's do a review of what we have done here so far. So basically what we have done here is, first of all, we have basically get a base image. So let's add a comment here. We're just going to say this is the base image where everything is going to be building. We created a folder, we exported the right port, and then we have copied the CS approach file and we did a restore. The reason what we have done this, in case there's any problem, we are basically stopping the processing of our Docker file directly here prior to continuing everything else. And we can actually here, what we're doing is we're doing separation of concerns. So basically we're dividing the steps into small steps instead of having one single big step, copy and restore. And that way we're actually able to see where is exactly it's failing in case there's any problems, and to allow us to have a bit much more control about debugging any issue that we might have faced. So what I'm doing here is I'm just copying the CS approach from my local directory, so from my here to the Docker container, and basically I'm restoring it. I'm just applying the .NET restore to get it, and once I've done that, I'm copying everything else, and then I'm publishing it inside a folder inside my Docker container, inside a folder called out. And once I have done that, I just specified a final image. Let's put it here. And basically inside of this, I'm copying the output of my publish from the first image to this one, and just specifying an entry point. And you might think to yourself, why are we copying it? Why don't we just use this? Because basically, if you take a look here, what we did is we have copied all of the source code inside our Docker image, and then we have published it. And we don't really want all of the source code. All we want to do is to have these types of DLL which exist here, rather than have the source code of our application. And by publishing it and then copying the publish, all we're doing is we are only getting these information that we currently see here, which is going to be our DLLs, our JSON files, so on and so forth, our configuration. We don't really need the actual source code. So that's why we're doing it. So once we have done that, let us check if our Docker image is actually building successfully. So we're gonna go to the terminal. Let's clear it up. Let's make it a bit higher. Let me see how it looks. Okay, great. I'm just gonna put Docker build, and then I'm gonna specify everything. I'm gonna tag it, and basically let's do it without a tag, and then we'll do it with a tag. So now we can see that our instance is running, and we have a problem here. Publish. Okay, I have a problem. I wrote publish wrong. Let's run this again. Okay, perfect. Now my build has been completed, and this is the ID that I got. As you can see, this ID is not really user friendly. So what I want to do is I want to give my image that I just created a name where I can actually refer to it easily. So let me clear this again. And well, for me to do that, all I need to do is put -t, and then I give it the name that I want. I'm just gonna call it formula KAS, so meaning formula Kubernetes. Now if I run this again, everything runs, and now we can see here that this is how I'm referring to my application. So once I have done this, now let us run our application in a Docker container, run it directly from the Docker container to see if everything is working as it should be. And for me to do that, I'm just going to put Docker run, and here I need to specify the ports that I want to connect to. So basically I'm just going to tell it that I'm going to connect to it from port 8083, and I'm going to map it to the internal port, which is going to be 80 once my application is running. And then I want to specify here my environment variable, and here I'm basically telling ASP.NET that it needs to listen to port 80 from my application, because if you remember, whenever we're trying to run our application, let's do it here in a new tab. If I do .NET run right now, as you can see here, it generates a random port, and I don't want that. I want to specify the port to be port 80 inside this container rather than having this random port. So that's why I need to specify here a random, a port that it needs to listen to. And for me to do that, all I need to do is just put ASP.NET core underscore URLs equal HTTP. Is it looking good? Let's clear it up and then we can continue. So clear. Okay, let's do it again here. So it's gonna be docker run, specify the port. I'm gonna utilize port 8083 to connect to port 80, and then I need to specify my environment variable, which is gonna be the ASP.NET core underscore URLs. It's gonna be equal to HTTP, and then we'll put here the plus sign, so it doesn't really matter what it is, and I'm just gonna put this has to listen to port 80, and then I'm gonna specify my image name, and I think I called it, we can go up and see what did I call it, formula. Okay, let's copy this. Okay, and now if I run this, we can see here that my application is currently running inside my container of port 80, but for me to connect to it, I need to utilize port 8082. So let's go back to my web browser, and I'm just gonna open it here. I'm gonna put localhost, and I'm gonna put here port 8082 / swagger / index.html. And now you can see here that this is my application running inside my Docker container. If I try it out, execute, we can see I'm getting the information that I need here, similar to what we have done. Now let's make sure that this instance that we are currently running is different from my local environment. So what I'm gonna do, I'm gonna update my local application, change the text in my get response, and basically see that both of them are completely separate. So I'm just gonna go back here, and I'm gonna come back to my controller here, and I'm just gonna say this is from my local, instead of local app, local computer, not Docker. And now in my other terminal, I'm just gonna run this again. And now we can see it utilized the port 5153. So let's go back to my web browser, and I think this tab refers to it. So now if I refresh, now we can see that if I want to execute this, we can see here that hello from the local computer, not Docker. And the other one, which is also still running, if I refresh, click, try it out, execute, we can see this is running from hello app, from the local app. So we can see here now I have two versions of my applications running, one running locally on my own machine without Docker, and one is running inside my Docker container. And you thought here, as you saw here, the changes that I did not automatically reflect inside my Docker image, because basically in order for me to update the Docker image, I need to basically do another build again. And once I do another build, it will basically update the current version of the image, and will basically, once I stop my container and run it again, it will be able to pick it up. So right now, if I just stop this for now, and in order for me to update my Docker image to have the latest version, I just need to run, let's clear it up. I just need to run my Docker build again. So I'm just gonna put docker build -t, and we called it formula Kubernetes. And now we can see it's doing all of the build process again. Let's clear it again. And now if I just run it directly from my Docker on port 8082, and I come back to my web browser, so this was before the update. Now if I refresh and I come here and click on try it out, execute, we can see here that I got the latest version inside my Docker instance, which is basically this is how we update it. So now that we made sure that my Docker image is running as it should be, I'm able to deploy it, or basically run my Docker image directly inside Docker. The next step is we're just gonna go a quick overview about Kubernetes, and we're gonna understand how that will fit with the Docker that we have created, how it will fit within a Kubernetes. So basically, Kubernetes, if we don't know, it's a container orchestration system. It basically allows us to orchestrate containers. So in this example, we only have one container to orchestrate, which is gonna be our application that we have created created. But mostly Kubernetes is being utilized if you have a lot of microservices and you want to make sure that they are all running in the right way. In case a container fails, it's automatically being another one will be able to pop up. There is auto healing, so basically in case there's something went wrong, the number of instances of my application is still spread out. In case there is a high load, it will be able to scale up and down based on the load that we currently have. So Kubernetes is an orchestration which is available from Google. I think in 2015 it went into the Cloud Foundation, and basically it is a way where we can actually deploy our containers to, and basically we can manage them on a large scale from there. For this video, to make it simple, we're just going to be utilizing a local version of Kubernetes on our machine, which comes when we install Docker Desktop. But basically you can utilize this if you're utilizing AWS, if you're utilizing Azure, Google Cloud, so on and so forth. And what we're going to be doing here is we're just going to be creating a single container rather than trying to manage multiple containers. So Kubernetes is a domain by itself, and there's a lot of information there about it. So if you want me to jump and give an example about how Kubernetes works and the structure behind it, please let me know in the comments down below, and I'll make sure I'll create a video about that. But for now, we're just going to be skipping all of those introductions. We're just going to do a very quick one to understand the different components of a Kubernetes cluster, and then we're just going to directly start by actually implementing it. But if you want me to have a much more deeper dive into Kubernetes, please let me know. So basically a Kubernetes cluster is, we can think about it as our big server in a certain way. So this server is going to be composed of multiple items, and the main thing is there's going to be three components that we need to take a look at. We're going to have the APIs, we're going to have the control plane, and we're going to have our nodes. So basically our API here is whatever how we are actually able to interact with Kubernetes. So basically, because a Kubernetes is a managed service, and if we want to communicate with it, there is an API set of APIs available for us that we can actually utilize, and these APIs are directly available from the command line. There's GUIs that we can utilize. There's a lot of different items that we can use in order for us to communicate with this API. But in essence, the main way that we communicate with our Kubernetes cluster is through those APIs, and we're going to be seeing how we can actually execute some basic commands against these APIs. So the second thing is we need to take a look at is the control plane, and the control plane, we can think about it as like the brain of our cluster, where it's actually manage everything that we need within our cluster. So we can see here scheduler is going to be responsible for making sure that all of our instances is running at a certain extent, and make sure that in case there's something went wrong, it will be able to publish new ones. The etcd is like a key value pair store, like a database where it store all of the different configuration that we need inside our cluster. Our control manager is basically something to keep the control plane up and running. We're not going to be really diving out of deep on how these works, but if you see this, you just want to understand what they do. The main thing that we're going to be focusing here is the nodes, and the nodes is basically composed of kubelets, and inside the kubelets we're going to basically have our containers running. So what we're going to be doing is we're going to be creating the actual deployment code for a node inside the deployment, and we're going to be able to see how we can put our Docker image inside this deployment. And once we have done that, we're going to be able to see how we can deploy to a single node, because it's at the end of the day, it's on our local machine. We don't really want to propagate it, but we're going to be able to see how we can create different replica sets. So we're going to have different instances of our application also running simultaneously. So that way we are basically able to see that we can scale it up, scale it down. We can make sure that we are covered on every single scenario that we might need. But this is a very quick introduction about Kubernetes, and basically Kubernetes worked in conjunction with Docker, so it's not a replacement. And Docker is not only the only container service that Kubernetes takes. Kubernetes can be adjusted to take different container systems, but just to make this video simple, we're just going to be utilizing for this reason Docker. So let's go back to, before we do any of that, make sure that you have an account open on Docker Hub, because we're going to be needing this account here to basically make sure that we have uploaded our image to it. So please make sure you have a Docker Hub account available, because that's what we're going to be, it's a free, you don't have to pay anything for it. This is what we're going to be using to host our images. So now that I have mentioned that, let's go back to my application. And what I want to do right now, I want to push this version of my application, Formula 1 K8S, to my Docker Hub here, so we're able to see it here, so we can utilize it inside my Kubernetes cluster. And you might think to yourself, okay, why don't we just, if it's available inside our own machine, why don't we just utilize it from within the local Kubernetes cluster? This is a more simpler approach because we don't really want to configure Kubernetes to speak to our local directory, but because we upload it on Docker Hub, and Docker Hub, it's a free open repository, we don't really need to do any configuration. Kubernetes will be able to find it directly inside the Docker Hub. But if we want to utilize our local registry, we need to do some configuration. So Kubernetes is aware of our local instance. We don't really want to do this right now. So, and the way we're gonna be able to push this is gonna be quite simple. So the way, let's go back here. I'm just gonna clear this up. And basically, the way you push it is just put Docker push, and then if you take a look, first of all, before we do a Docker push, we need to tag it in a certain way. So we need to put Docker build dot and then -t, and the way we want to tag it is, first of all, it's going to take our username from Docker, which is going to be Mohamad Lawand in my instance, and because you can see here, this is my username, Mohamad Lawand. And if I go to my profile, and you can see this is my username. And once I do that, I just want to specify a /, and once I have done that, I'm going to specify my image name, and this is going to be Formula K8S, and I'm just going to give it a version 1. Now if I do that, we can see here at the end that my image has been tagged with this. So now if I clear it and I do Docker push, and then I specify the name, which is going to be Mohamad Lawand / Formula K8S V1, and now you can see here that it's starting to push. Perfect. Now if I go back to my Docker repository and if I refresh, now you can see here that a few seconds ago I was able to actually push my Formula K8S to my Docker Hub. Now it's available online on Docker Hub, so for me to utilize. So make sure once you push it, you are able to see your Docker image here. So once we have done that, the next step is inside my root directory, I'm going to be creating a new file, and this one is going to be called deployment.yaml. And yes, Kubernetes work with YAML. So before we do anything, just to make sure that our Kubernetes instance is running, I'm just going to clear this, and we're just going to put kubectl, and kubectl here allows us to communicate directly with the Kubernetes API that are available. So if we go back here, so basically once we utilize kubectl, it will allow us to communicate from our terminal with our Kubernetes cluster, which is available here. And if you want to make sure that our Kubernetes cluster is running, either by when you click on the whale icon, you can see Kubernetes running, or if you click on the dashboard, you're going to be able to see it here, Kubernetes running, just to make sure that if you want to double check that your Kubernetes is running. So now that we have kubectl, I just want to put get all. And basically here we're going to be seeing that I don't have anything running inside my service rather than the only Kubernetes service, which is exactly what we want at this moment. So now what I want to do is I want to start creating my deployment, and then we're going to actually see how we can deploy this deployment. So first of all, I want to specify my API version. And in this case, it's going to be apps/v1. And then I need to specify what kind of service I want to create, and this is going to be a deployment. Perfect. So now that I have specified my API version and what kind of deployment that I need, then I need to specify some metadata. And this metadata is really important because basically the way Kubernetes is able to filter out through different deployments, different pods, different systems is through metadata and searching through metadata. So it's really important for us to make sure that the metadata which we input are valid and actually represent of the changes that we currently have inside our Kubernetes cluster. So metadata, and then I'm going to specify my name. I'm just going to call it Formula app deployment, So that's what we're gonna be doing, deployment. And then I'm gonna specify the annotation. And here, because it's gonna be a deployment, I'm just gonna say that this is gonna be an initial deployment. Once we wanna actually upgrade it, so let's say we did some changes on my Docker image and I wanna update it from version 1 to version 2. Inside my annotation here, I specify that this is upgrading the version of the container from version 1 to version 2. So that's way I can actually see that my different deployment stack, and if I wanna revert back to a previous deployment, I can do that. If I wanna view all of my deployment history, I will be able to see that as well. So here inside my annotation, I'm just gonna specify here my Kubernetes.io/change cause. And I need to specify the message. I'm just say initial deployment of the app. Once I have specified my annotation, the next thing that I need to do, I need to specify my spec. And the specs here is going to be allowing me to configure this deployment and giving it all of the specs that I need. And here I'm going to specify how many replicas or how many versions of my application I want to run simultaneously. And for simplicity's sake, I'm just going to say 5. We can make it 1, we can make it 10, 100, as many as I want. Just for simplicity's sake, I would just want to make it 5. And then once I specify my replicas, I want to make sure that I specified my selector. And the selector is going to work here on the labels. Match labels, and I'm just gonna call my app right now formula-app. And basically the reason I have the match label available here, let me close this so we can see it in a much more all of it on one page, because we're going to be referring this when we're actually defining our container. So once we have done that, the next step is now we need to specify the template. So if we go back, make sure this is YAML, so make sure spacing is correct. So right now, as you can see, I want two back spaces under selector. So now we can see that I'm directly under selector. And I want to specify here template. And inside my template, I want to specify my metadata. And in this case, I'm going to specify the name of my container that I want to run. And in this case, it's going to be my formula. I can call it whatever I want. Let's just make sure my formula app or my formula K8s, anything that I want. Let's keep it formula app just for simplicity's sake. Actually, let's keep it as SKS. And then what I want to do here, I want to specify my labels again, because this is labels I'm going to utilize to match. So here we're going to see, first of all, it's going to be the environment that I want to make sure this is going to be a production environment. Then I'm going to specify the app, and this is going to be called formula app. And then here I want to specify the way I'm going to be referring to this. So app.kubernetes.io/name, and here I'm just going to specify it as formula app. And this one here, the app.kubernetes.io/name is like a reserved name or reserved key within my labels. So if I'm trying to refer to this instance from anywhere else, or let's say from another service that Kubernetes is using, I can use this directly from here. So once I have done this, I need to specify now the spec for this template, for this Kubernetes, for this container service that I'm trying to create. And we need to make sure that I'm under metadata. So again, spacing is really, really important in YAML, specifically when we're running with Kubernetes. And here I need to specify my spec. And as you can see here directly, I need to specify my containers. And in this containers, I'm going to specify the name for it. And we're just going to call it formula app. And then I need to specify my image. And this is why we deployed it into Docker Hub. So right now, if I go to Docker Hub, this is going to be my image name. So I can just copy this. If I click here on tags, we can see my different tags, and we can see that I'm version 1. So I'm just going to take this, and I'm just going to put that this is going to be version 1. And once I specify my image, now I need to specify the ports. So this one is going to be, if you remember the command that we did to run Docker Hub, to run Docker local on our machine, we specify the ports for my application. And then here what I'm going to be doing, I'm going to refer to this port as a name. So basically, in order for me to route traffic So Kubernetes by itself is going to be closed, and we're not going to be able to communicate with it directly. So what we need to do is we need to create a service within Kubernetes that can allow the flow of traffic from the outside network to its inside network. And in order for us to do this, we can either utilize directly the port 80, or we can give it a name. If we give it a name, we can utilize port 80 is fine, but the reason I'm mentioning here the name, just so you can see if you have multiple apps and you don't really want to memorize all of these ports that you are giving to your apps, you can just refer to a name. So that's why we're just giving all different options that you might need to utilize. So here, if under containers, again, spacing is really important. We just need to give it a name, and I'm just gonna call this http-web-api. Now, once we have done that, make sure that you go back under ports, and we need to specify the resources. We want to tell it how much resource it needs to allocate to this container to run. And I'm just going to say it's going to request CPU. I'm going to make it very small, which is going to be 100 M. And then we're going to make it the memory. So here it's going to be like 0.1 version of our CPU. And we're going to give it like 100 megabytes of memory. And then other than that, I'm going to specify the limits, so it will not be able to get more than that. So the CPU is going to be maximum 200, 0.2, and my memory is going to maximum of 200 megabytes. We don't really need more than that for a simple empty API. Okay, once we have done that, now I need to specify my environment variable. If you remember, inside my terminal, I had to specify my ASP NET core URLs. So I will tell the container that it needs to run on port 80. So now this is what I want to do here. So again, make sure that you are under resources, and then here we need to specify our environment variable, and I'm just gonna give it a name. I'm gonna put the ASP NET core underscore URLs, and then I'm gonna specify the value. In this case, it's going to be http //+:80. And here basically I'm just specifying the same environment variable that I specified for my container. So all of that here that you're seeing all the way from containers all the way down is just giving the configuring our simple Docker image, and everything you see on top is basically we're giving Kubernetes some information for it to actually be able to build this image for us. Let me see how this is looking. Okay, I think it looks good. So now, once we have done that, the next step is, as we said, I want to be able to communicate with my... Actually, before we do that, let's open our terminal. And inside my terminal here, I just want to, first of all, apply this. So kubectl, again, this is the CLI command that allows me to communicate with Kubernetes. I'm going to do apply. And then I specify the file, which is going to be -f, and I'm going to put deployments.yaml. And if I run this right now, we can see that it has been created. And if I want to check this out, I can put kubectl get all. And now, as you can see here, let me zoom this a bit, make this a bit bigger. As you can see here, I have 5 versions of my application running, which is here version 1, 2, 3, 4, 5. We can see that my deployment is here. We have 5 out of 5 because we specified 5 replica sets. And we can see here that everything is running as it should be. So if I get this again, we can see that the age is just keep getting bigger and bigger. But something here to keep in mind is that all of this is managed by here. So for example, if I want to change my replica set from 5 to 10, if I save this, I do another kubectl apply -f and specify deployment.yaml, we can see it's set configured now. And if I put get kubectl get all, now we can see that I have more instances running. We can see some of them are older and some of them are new, which has just been created. And this is basically allows me to view all of my containers and basically all of the pods. So if you take a look here, we can see that you have pod and you have the container inside of it, pod, container inside of it. So this refers back to this. So inside a node, we have those different kubelets, and you can see here that basically inside my single node, I have different kubelets, and every single one of them have a different node available. I have a different pod available. So that's just something to keep in mind. So now I'm just gonna revert it back to 5 and see how that will work. So now let's make it 4 even. And now if I just do kubectl apply -f and put deployment.yaml, and that I put get all. Now you can see here that some of the instances are being terminated. I'm only gonna able to have 4. So now if I go back, get all, we only have 4 running, and everything has been updated. Perfect. So now, once I have done that, now I know that my application is running inside Kubernetes. They are healthy. I have 4 out of 4 based on my requirement. But how can I connect to it? Because right now, everything is running inside the walled garden of Kubernetes, but I want a way where I can actually propagate the traffic to it. So let's see how we can actually implement this. So after I specify my deployment, let's close this. I'm just gonna do these 3 lines here. So this is really important. So these 3 lines, it will allow me to specify different commands for Kubernetes. It will basically like creating a new file and I'm able to actually give more commands. So what I want to do here is I want to create a new service. I'm going to put API version, and it's going to be version 1. And here I'm going to specify the kind of this version service. I'm going to say it's going to be a service. And from here I want to specify the metadata. It's going to give it a name, and I'm going to give this name my load balancer service. Actually my LB service should be enough, because basically, let's go back here. What I want to do is I want to specify some kind of a load balancer which is available here, and this load balancer is going to be responsible for receiving traffic from the outside and routing it to the different nodes that exist and different pods, because right now I have 4. I cannot really decide on which one of these pods that my request is going to go to. And for this I need some kind of a load balancer which is going to be responsible for managing that traffic. It's going to see which pod is available for me, and based on that it's going to be forwarding the request to it, because I don't really want to do all of the management of this by myself. I can just utilize a load balancer for me to manage this for me. And now if I go here, once I have done this, I need to specify the spec for this load balancer, and I'm gonna give it a selector. And basically the selector here, I need to make sure that it's gonna be matching whatever I specified here, and in this case it's gonna be app.kubernetes.io. So let's copy just this, because this is where we're referring this load balancer to this deployment. We are connecting them with each other. So it's really important for us to make sure that we got this right. The same selector, so make sure that app.kubernetes.io/name, this needs to exactly match this one. If we don't, it's not gonna work. So once we have specified the selector, the next step for us is we need to specify the ports of how are we going to be able to communicate with this load balancer. And here I'm just going to say, give it a name. I'm just going to say formula -app -port. And then here I'm just going to provide the protocol. And it's going to be over TCP. And then I need to specify the port that I want to utilize to communicate with it. I'm just going to utilize port 8080. And I want to forward this port to target port. It's going to be port 80, because this is what the port that we have specialized here. As you can see, this is the port that we are targeting. And this is the container port which is available. And the last thing that I want to specify here is going to be the type of this service. I'm just going to make sure that this type is a load balancer. As simple as that. So now what I did here, I just created a load balancer. And this load balancer, I'm just making sure that it matched the deployment that I had before. And I'm specifying the ports for this load balancer where it needs to take the request and forward it to. As simple as that. Now if I go back to my terminal, and I do the same command again. So first of all, I'm going to put kubectl get all. We can see everything is running. Now if I want to delete it, I'm going to put kubectl. We don't really need to delete it, but I just want to show you the command to delete -f. I'm just specify the deployment, it's going to tell me you cannot delete a service because it does not exist, but the first one, it does exist, which is perfectly fine. Now I'm just going to run it again. Kube, let's clear this up. And then I put kubectl apply -f deployment. And now we can see here a service has been created and my deployment has been created. So if I put kubectl get all, here we can see actually that my 4 containers is running as it should be. But something really important, you can see now I have a different service, which is my load balancer service. And now as you can see, it has an external IP that I can utilize to connect to. And this external IP is going to be on port 8080. So let's see how this is going to work right now. So if I go back to my web browser, and this should be stopped right now because we stopped the container. This should be stopped because we also stopped the application from running locally, or we didn't. Let's stop this. Still running, let's stop this. So now if I refresh, it's stopped. Perfect. Let's copy this URL. I just want to update the ports to port 8080. And now if everything goes to plan, I should be able to see that my instance is running. And now you can see that my application is running from within Kubernetes on port 8080, which I have specified here. And if I run this, try it out, execute, now you can see hello from my local computer. Now let's see how we can actually update this. So right now what we have done is we have created our deployment, creating our load balancer. We are able to communicate with my application from within my local browser. So it means the connection is coming through to my pods where my container is running. Now what I want to do, I want to show you the process of what we can do in order for us to actually update those containers from one version to another. So I'm just gonna go back to my application, gonna go back to my controller, and I'm just gonna say hello from Kubernetes. That's it. And the steps is gonna be as follow. So first of all, what I want to do is I wanna create a new Docker version, basically a Docker image. So Docker build dot dash t, and then here I'm going to specify the name of it, Mohamad Lawand / formula K8s, and I'm going to give it version 2. So now it's building. Perfect. Now the next step is I want to build it. So push it. So I'm going to put Docker push Mohamad Lawand / formula / K8s version 2. Oh, okay, now it's pushing. Okay, great. Now if I go back to my web browser and I go to Docker Hub, if I refresh this one, we can see that we're going to have version 1 and version 2 available for us now. So we can see here we have version 1 and we have version 2. So what I want right now, I want to utilize version 2 inside my application. So if I go back to my deployment, and what I want to do here is, if I want to just change it up. So first of all, I want to change the cause. So I'm just going to say updating my Docker image from v1 to v2, and then here what I need to do is just specify a new version of my Docker image. Instead of v1, put v2. Save this, and now again kubectl get all, make sure everything is still running as it should be. I misspelled kubectl. Now we can see everything is still running. I'm just gonna put kubectl apply -f deployment, and now we can see here that the new deployment has been configured. And now if I go back to my web browser and I refresh this, first of all, let us just make sure that everything has been updated. So kubectl get all, we can see here that everything is running, because now we can see the age is 16 seconds because everything has a new version now. And if I click on this Let's do a refresh. Select this, try it out, execute. Now you can see here that I'm running on the latest version, which is going to be hello from Kubernetes. And basically, once we have done this, we basically got the latest version of our Kubernetes instance available directly inside, the latest version of our Docker image inside our Kubernetes instance. So with that, we were able to see how we can actually utilize Kubernetes in order for us to host our application. And let's do a quick summary of what we have done so far. So basically, what we have did is we first created our API. We did some minor changes to it. Then we created our Docker file for it, where we are actually able to build it and build an image. Then we have deployed this to our Docker Hub, where it's available for us. Once we have deployed it to Docker Hub, we created a deployment.yaml file where we specified all of the deployment code that we needed for Kubernetes. Once we have done all of that, we created another load balancer service, and this load balancer service is going to be responsible for propagating the request from my local machine to my Kubernetes cluster. And once we have done this, we are able to actually communicate with it. Then we have seen how we can actually update the container itself by first of all creating a new version of our Docker image, pushing it again to Docker Hub. Once we push to Docker Hub, we just updated our deployment file, and then once we have done this and applied it, we were able to directly get the response that we need, and we are able to directly have the latest version of our Kubernetes instance, our application instance inside our Kubernetes service. So I hope this video was helpful. Please like, share and subscribe if you like this video. It will really help the channel as well. If you'd like to support me, please consider supporting me on Patreon or buying me a coffee. Thank you very much and have a great day.